Hello, my name is Yes Raj Bista, and my software ticket number is 240224. And today I'm going to discuss about my thesis project, which is Oracle Log Anomaly Detection Framework for Predictive Fault Management in Telecommunication System using machine learning. Continuing with my project, my project focuses on analyzing Oracle database alert logs and automatically detecting abnormal system behavior using machine learning techniques. Oracle logs are normally raw text files, like it contains timestamps and error messages, warnings, and system events. These logs come in very high volume in telecommunication systems. The first step of my project was to load these logs, and what I've done here is that I have created a data structure for uh, my code, and I've imported all the required libraries, which are Panda, NumPy, Matplotlib, sklearn, and I have used different RNN models such as LSTM and other networks as well. And for the matrices, I've used a classification report, confusion matrix, and REC AOC curve. So I have collected the first 1000 characters of logs, and what I've tried to do is I try to separate the logs and dissipate them into different patterns. I have the main column, which I divide into timestamp, message, and raw text, and I take the exact timestamp and the message and raw text into different columns. And by using the help of NumPy, I have taken if my data, if my column has any deadlocks or any table spaces or archival checkpoint, I have done a flagging. We can call it a flagging. If it is y, then it is if true, and if it is false, then it is n. The second thing that I've done is clean them and convert them into a structured table that I suppose machine learning could use. This includes extracting like timestamp, log label, message text, and whether the log contains error codes such as ORA 00600 or TNS 12514. And as you can see here, my log label, and you can see if it has error or not, or error rate rolling. And this prepares the data so that it can be used in for automated analysis as well, instead of manual log. So we can see the diagram over here, and this first graph shows how much log entries are generated each day across the entire year. We can clearly see that the log volume is not constant in this first log volume, and at the start of the year there are a few significant spikes, and which indicate period of unusually high system events or errors, and towards the end of the year the volume rises, showing a number of more predictable patterns. And the second diagram is the log level distribution. Here we can see that there it is divided across three categories: info, error, and warning. Here info log dominates the system, which is expected because Oracle database generates a large number of routine operational messages, and red bar represents error logs, which is significantly fewer, but much more important than warning logs, which are very negligible. And the third diagram we can see is the log by day. So it is especially between 6 a.m. and 6 p.m. the volume tends to be during peak business hour. This pattern tells us that when the system is under the most load, and helps identify whether the anomaly are most likely to occur. It is support capacity planning and maintenance scheduling. And after we have done our EDA, we go into our machine learning features. Since machine learning model do not have understand plain text, we are trying to convert them into numerical patterns, which is called a feature engineering. This means that the log messages are converted into meaningful numbers, and so it would be helpful in the pre-processing time. So there are several techniques such as one hot encoding, and like calculating message length, rolling averages for error rates. So we've done that. Creating this hybrid feature is important because telecom system have dynamic and unpredictable behavior, and combining these signals model detect anomalies and accurately. So after this, before training the model, all numeric features were standardized using a technique called standard scaler. This ensures every feature has a similar scale, so that the large value feature do not overpower small value ones. For example, like time interval may be in seconds, while ratio may be 0 to 1. Models like one class SVM and auto encoders are very sensitive to differences in scale, so scaling is like an essential step. So I have used the machine learning that I've used are SVM, isolation forest, one support vector machine, and auto encoder. Like isolation forest works by isolating unusual data points using random decision tree, whereas one class SVM creates a boundary and normal around normal behavior and flags outside the boundary as an anomaly, as an outlier. The autoencoder is a neural network that learns to construct a normal pattern, and anything that cannot be constructed correctly is considered an anomaly. Each model has different strength, and model must agree before marking something as abnormal. This gives a stable and reliable pattern. So we can see while using the LSTM, there are a lot of neural network work going on, and there is a dense repeat vector LSTM and dropout. After these many epochs, our LSTM is trained. So after training these models, I evaluated that using accuracy metrics such as precision recall, F1 square, and AUC ROC. I compared the traditional rule monitoring system to our Oracle Enterprise Manager, and the F1 score is 0.87 and ROC AOC is 0.94. So the framework that has reduced false positive by 61% and reduced average detection time by 25%, 25 minutes to 9 minutes. So finally, I have generated a output such as feature importance chart, and finally we have created a Streamlit application to see our log file anomaly detection. So we can either upload our log file, but if that is not the case, there is an already provided sample data, and when we use this sample data, we can see here there are like six total number of logs, 3 lines of error warning, 2 ensemble anomalies, and 33% detection rate. And and we can also even download the CSV file here, and we can see whether out of the 6 logs, if the 0 comes in all the 5 columns, then it is normal. But if there is one an isolation LSTM, SVM, and ensemble, then it is an anomaly. We can determine whether the error in our log message is either normal or anomaly. and this is my project. Thank you very much.